Alright, what's up guys? In this video, gonna pick up with some complex analysis here. It's gonna be dealing with some contour integration. So basically given this contour integral, z bar dz, to basically give us z of t, which is equal to t minus ti, and they basically give us the limits there. So we're asked to evaluate the contour integral over c. Now for most of the contour integrals, it'll be complex, and you may have to sketch the complex plane, because doing integration in a complex system, so to speak, is slightly different than doing it over a real plane. So in some cases you do have to be very careful. But in this case, we really don't need to do too much here. We just need to build and evaluate this. So all we really need to do is just find the complex conjugate of z, the z bar that you see there, or the z with the little line over top of it, is denoted z bar. That just means the complex conjugate of z. And when I say the complex conjugate of z, I'm talking about the complex conjugate of z of t, which is t minus ti. So if we identify z bar, what you get is just a complex conjugate of z. If I take the complex conjugate, so given that z bar, that means that z bar is going to be t minus ti multiplied by the complex conjugate of that, which is t plus ti. Okay, so that's what z bar represents there. Hopefully you guys can see very well, just the lighting. Okay, so that being said, since z bar is the complex conjugate, we can now basically kind of multiply those two together. So if we multiply the t minus ti, this will allow us to expand it out, plus the t plus ti, which is complex conjugate. Looks like that'll give us t squared minus t squared. This will give us a I squared. Now remember, I squared is equal to -1, so keep that in mind. Okay, well, with that being the case, that means that since this t is already negative, since I squared is -1, that changes to a positive, so this actually just becomes t squared plus t squared, which is just 2t squared. Okay, now what am I missing? Okay, so now that we took care of the expanding part, we can find dz over dt, because we want to evaluate the contour integral over this over c. So that's going to be dz over dt. That's just a derivative of z of t. That's just 1 minus I. Or if you want to, you can write it as dz is equal to 1 minus I, and then you can put the dt behind it. Okay, so now that we have the derivative of z of t with respect to t, so given this contour integral, we got z bar dz. Well, if we set this up, we know the limit's going to be from -1 to +5, and on the inside here, we just have to place everything in. So this would be 2t squared, and then 1 minus I, and you put the dt behind it. Now it's just an integral at this point. There's some constants in here. The 2 is a constant. The 1 minus I is also a constant. Remember, we're doing complex integration, which is a little bit different than, slightly different than integrating over a real plane. They got -1 to 5. I just pulled out the constants. And then we got t squared in here, dt. So this will help us get the answer to this contour integral. All right, so let's continue here. If we apply the constant multiple rule with the integrals, the 2 and the 1 minus I just comes over. Applying the integration power rule, that'll be t to the third over 3. And now we evaluate this from -1 to +5. So the fundamental theorem of calculus says, well, or part 2 of the fundamental theorem of calculus says that the 5 gets subbed in first, then you sub in the -1 after that. 5 cubed, that's 125. That's going to be over 3. That doesn't divide out evenly, so we just leave it as 125 over 3. If we stick in the negative 1, we'll get negative 1/3. So this essentially changes to 125 over 3 plus 1 over 3, because we have two negatives there. And remember, to add fractions, you need common denominators. So if we add the two, we'll get 126 over 3, which I think is 42, but let me just quickly check. 126 divided by 3, yes, 42. So you always want to reduce if you can. So this would be 42 when we actually divide the 126 over 3. So applying the constant multiple rule again, so we got 2, 1 minus I, and we just multiply all of that by 42. The 2 and the 42, if you want to, you could just write it like this. If the parentheses makes it look a little, it doesn't look good like that, so put parentheses. I see some students write like that. If we multiply the two numbers, the 2 and the 42, 2 times 42 is 84. So this would be 84. And we can't really do anything with that 1 minus I. So it's just 1 minus I. So your final answer for this contour integral, if you actually go down here over C, we can actually write the answer here. And I posted a solution to this a couple days ago, but I don't think, maybe I did. I can't remember whether I did or not, but I didn't get a chance to actually do the video. So the answer to this contour integral is just going to be 84 multiplied by 1 minus I. And that's your answer. So that's complex integration. I've done some videos on contour integration before, but not very many. But so there are some videos on online, but not very many. Again, I primarily stream my math videos from Instagram, so if you want to see the Instagram videos, you're gonna have to watch the Instagram. I don't stream from Facebook very often, but I thought I'd just throw a couple of problems on here for you guys to see. So please check out my Instagram page. I will be returning to doing daily mathematics videos Sunday night, because college will be starting back up for you undergrads. Most of you will be probably going back on Monday or sometime this weekend. So I'll try to get some content uploaded, and if you got any questions, let me know. But other than that, I will see y'all next time.